Okay, so this video is to help you understand percent composition, and in order to do percent composition you are going to need your periodic table and a calculator. So get those things out and have them in front of you. This also is going to utilize your notes. Okay, so have your notes open to the proper page for percent composition. Okay, now all percentages, and we're going to do percentages again here in a little bit, are set up the same way. They're always the part you're looking for over the whole thing multiplied by 100. And so what we have here is you have your units canceling out. So if I have grams over grams, they cancel, and then percent here is actually my unit. When you are calculating these for chemistry class, you don't actually want to use your percent key on the calculator. Percent is just considered to be the unit. So it's just really important to read the problem closely, figure out what's the part you're looking for, what's the whole thing, and then you can multiply it by 100. So in order to do this, what we would do is we would find the mass of each of the components. This is where our periodic table is going to come into play. And then you divide it by the total mass of the compound and then multiply it by 100, as I was saying. So here's our first problem. Calculate the percent composition of a compound that is 29 grams of silver and 4.30 grams of sulfur. Okay? So we're just given some basic elements to look at this. So you're looking at the percent composition. Now it doesn't specify, okay? It doesn't say if I want the percent silver or percent sulfur. So I assume I have to get the percentage of each thing. So, and composition, in case you don't know, just means what it's made of. Okay, so that's all composition means, what it's made of. Okay, so I am looking for my part over my whole thing, and I'm going to multiply it by 100. So since it doesn't specify, I'm just going to use my silver first. So let's say I am curious about the percent Ag in the compound. Well, my part is 29.0 grams of silver. My whole, in this case, is the mass of these whole things, both those things added together. So I need to do 29.0 plus 4.30. So this is where the calculator comes into play. So 29.0 plus 4.3, and that gives me 33.3 grams. So my total mass of the compound is 33.3 grams, and multiply it by 100. So take the 29, divide it by the 33.3, then do it times 100, and again you want to do this all in one step in your calculator. And on my calculator I get 87.08708 ... Okay, more numbers after that. We do want to round for Sig Figs in these problems. They do not go away. Okay, so if we are looking for our Sig Figs, here I've got 3 Sig Figs, and here I also have 3 Sig Figs. Same thing here. This 100 is considered infinite. It's an exact number. So I want to keep the first 3 numbers. Okay, and I look to the next number to round, and 87.1% Ag. So that's part of my answer, is 87.1 Ag. Now, again, I'm asked for the percent composition and I'm not asked for a specific thing. So I need to get the amount of both of them. At this point, you have 2 choices. I can do the same process, percent of sulfur, and do 4.30 divided by 33.3, because my whole thing is going to be the same. Or I know that all my percentages add up to 100, so I can do 100 minus 87.1. And either way, I am going to get about the same answer. You might have a little bit of difference because of rounding, But essentially what it boils down to is 12.91% sulfur. And that is my answer there. So there's my two answers. 87.1% silver, 12.9% sulfur. Together the two add up to 100. So that's one type of percent composition problem that you'll see. Here's another type where you're getting it from the formula. This is more often what we're going to do. So if you know the formula, you can assume you have 1 mole of the compound. And if you know you have 1 mole of the compound, then you know the mass of the pieces and the whole. Okay, you know your part and your whole, because we know the values that come from the periodic table. So this is where the periodic table stuff is going to come in. So if I'm looking at a problem like this, calculate the percent composition of C2H4. And C2H4 is also known as ethene. So if I'm looking to do part over whole times 100, okay, then I need to figure out what my whole thing is. Well, my whole thing in this case is the molar mass. So I want to get the molar mass of C2H4. So I have 2 carbons, and carbon off the periodic table is 12.01. And if I multiply that, that gives me 24.02. And I have 4 hydrogens, and each hydrogen's 1.01. And I do that math, and it's 4.04. And then I add those two things together, and I get 28.06. So that's my total molar mass of the compound, is 28.06. But what's really nice is we already have our parts. So here's the one part, here's the carbon, here's the other part with the hydrogen. So that's going to save us some trouble when we do our calculations. Okay, so let's say I just do the carbon first because it's on top. 24.02, that's my part, and that's grams, divided by the whole thing, 28.06. Again, my molar mass times 100. Use your calculator to solve. 24.02 divided by 28.06 times 100. Okay, and what I get is 85.60. Okay, and that's percent carbon, because that's what I was looking for in this first one. Again, now at this point you have two choices. You can subtract from 100, or you can set up the math. So if we're doing our hydrogen now over here, I can do it two ways. 4.04 divided by 28.06 times 100. Or I can just do 100 minus 85.60. Now that is going to change my Sig Figs just a little bit on it, but either way you will still be correct. So 100, I'm just going to do the subtraction because to me that's really simple. 100 minus 85.60, and that gives me 14.4% hydrogen. Okay. So again, as I'm being asked the percent composition, here's my two answers right here. 85.60% carbon. The other 14.4% is the hydrogen. Okay. The only other tricky thing is getting you to practice your naming skills still. Okay, so this time we want to calculate the percent composition of aluminum carbonate. So now I need to figure out what is the formula. That's what I got to figure out. What is the formula of the aluminum carbonate? And then from there, I can do my percent composition. So aluminum on the periodic table is Al, and Al has a +3 charge. And then I have carbonate. Carbonate has that ATE ending, that 8 ending. And so that tells me it is a polyatomic ion. And I should check the back of my new periodic table. Okay? If you check the back of your new periodic table, you see the CO3 has a -2. So I have aluminum, Al plus 3 with a CO3 with a -2 charge. And I want to add them up to 0. I want them to cancel out to 0. So if I add another aluminum, that gives me a total of a +6. And in order to get a -6 to cancel out to 0, this is what I would need. I would need 3 of those carbonates to get a -6. So that means I would need 2 aluminums. And since I need more than 1 carbonate, I would put them in parentheses like that, and then however many carbonates I needed outside. So Al2CO3. So that's my formula there that I'm going to use. So I'm going to erase the ink on this slide to make it a little bit easier to see again. So here's our formula we just figured out, Al2CO3, 3. All right. So again, with this one, the part over the whole times 100. My whole is my whole molar mass. My parts are the individual elements that I'm looking for. So I need to get the whole molar mass of all my elements here. So 2 aluminums, and aluminum is 26.98, and I do that math times 2 gives me 53.96 grams. Okay, and then when I do my carbon, remember that's like having an invisible 1 right here. So 3 times my invisible 1, I have 3 carbons times 12.01. That's 36.03. And then I have 3 times 3 for my oxygen. So 9 oxygen, and oxygen on the periodic table 16.00. So 9 times 16 is 144.00. I add those 3 up to get my molar mass. 53.96 plus the 36.03 plus the 144. And for this I get 233.99 grams. So that's my whole right there. My aluminum carbonate has a molar mass of 233.99 grams. So again, I'm going to clear the ink so I just have more space to work. So I'll rewrite our formula, Al2CO3, 3. And we said our molar mass was 233.99 grams. Grams. So the part I'm looking for, the aluminum. So my 2 aluminums had a molar mass. We're doing aluminum first here, just because it's the first element. It really doesn't matter. 2 aluminums, 53.96 divided by my total molar mass of 233.99, multiply it times 100. And that's what I'm doing right now in my calculator. Okay, and I get 23.0608, etc. But I look here and the 53.96 is for Sig Figs, so I'm going to do this. 23.06% aluminum. I'm going to use 4 Sig Figs. So sometimes parts of these problems will have differing amounts of Sig Figs, and that's okay. Next, I'm going to do my carbon. So here's my carbon next. I do 3 carbons. My 3 carbons were 36.03 divided by the 233.99 times 100. Okay, and I do that math. Whoops. Divided by 233.99 times 100. And again, this is going to be 4 Sig Figs. Whoops, I made a math mistake. 386.03 divided by 233.99 times 100. And again, this should be 4 Sig Figs, so that's 15 point... Well, I got 398, but I want 4 Sig Figs. So that's really 15.40% carbon for that one. And lastly, to do my oxygen. For my oxygen, I had the 9 oxygens with a mass of 144.00. So you can see that 144.00 is actually going to be 5 Sig Figs. The zeros at the end, these 2 zeros count because they are trailing zeros with a decimal. So 144 divided by 233.99 times 100, and that gives me 61.541% oxygen. Okay. So for the percent composition, those are my answers. Let's get a little more color on here. So here's my one answer, my 23.06% aluminum, 15.40% carbon, and then my last answer, 61.541% oxygen. And that's the extent of percent composition. Please see me in class if you have any questions.